Alright guys, here's the video for number 3. When we look at this one, we're going to notice that I've labeled these because this one, I've done it ahead of time, and it's going to be a little bit bigger. So if you've got a graph that only goes up to like -10 or +10, you may want to rescale that, maybe count by 2's instead, and that might be a way that you could get around running out of space on your paper. If you're using a larger sheet of graph paper, you can just give yourself a little bit more room. Just as a side note on this one, you wouldn't know that ahead of time, but now you've been told, so it'd probably be a good idea. You look at the top one, and one thing I notice, big on using zeros for things because of the relationship they have. If I take x and I take away 2y, I get 10 in that top one. Well, if y was 0, then it would just be x equals 10. So at x equals 10, we can go ahead and plot a point right there, and that's going to be something we can use. In addition to that, if x was 0, and I'm going to have to write this one out just to make it a little more sense. If x was 0, then 0 minus 2y would equal 10. Well, that would mean that y has to equal -5 at that point. And if y equals -5, that's down here. That gives us a little bit of a scale that we could use, or a slope. It goes up 5 and over 10 to get to each one. Well, that's the same as going up 1 and over 2 each time. So it might be to our benefit to just go ahead and go over another point or so, and then we'll be able to see enough to see where that one's going to end up. So when we go ahead and put that on there, we can see that that line has a positive slope of 1/2. It's got a y-intercept of -5, but I didn't have to have that in slope-intercept form to graph it. I could have made it that way, and that would have been okay. With 3, it's already in slope-intercept form, so I feel like I should use that if it's there to us, the slope and the y-intercept. The y-intercept is -11, and that's going to be easy to plot since I pre-labeled my graph here at -11. We'll see that. If I have to go up 1 and over 1 because the slope is 1, well, I could keep doing that and have quite a few points pretty easily that's going to describe that graph. Then you can go ahead and connect that so you can see how having a larger graph comes into play here a little bit. I want to be really careful, so I'm looking really close at my grid lines to try to get that completely right, and I feel like I did a good job of hitting those of a perfect 1 over 1 slope. These two points do cross, or these two lines do cross at a single point, and there is the point of intersection. And at first glance, it looks like it's at 12:1. Well, I'd want to check out that for sure because this gets a little confusing when you get out that far, and you're hoping your graph is accurate, but sometimes it just might not be. So if x is 12 and y is 1, and I put those back into the original here, I'd have 12 minus 2 times 1 equals 10. Well, that's true. And on this other one, I'd have 1 equals 12 minus 11, also true. So that's the only point, the only value for x and y that would make both of those equations true. There's lots of different coordinates that would make the first equation true, a lot that would make the second equation true, but the only one that makes both of them true at the same time is the point 12:1.